There's some more examples about stereoisomers, the type that we've been talking about, having groups positioned differently in the space. So let's try to find out the relationship in molecules. So I'm gonna do two drawings here, and this is cyclohexanol, and that is one conformer with the OH in equatorial. And now I'm gonna do this molecule. So what is the relationship between these two? Actually, these two is same molecular formula, same connectivity, but what happens here is that this two is actually related as the flip chairs. So these two are conformers of the same molecule, so they are the same. They're simply conformers. There are two flip chairs. And now let's do something else. I'm drawing again chairs. In this OH is in axial. I'm going to do an OH here in equatorial. And that's another drawing of another chair. OH in axial. OH axial here again. Now first, let's check. Molecular formula is the same. We have this cyclohexane, and we have these 2H. Now, connectivity is the second thing that we're going to be checking. So we see here OH in carbon 1 and 2, OH in carbon 1 and 2, numbering just the other way. But now notice that it's not exactly the same thing. This is, say, pointing up, and this is also up. So we will say that this is cis, so up, up. And this actually, and this is up, up. In this conformer, we have axial, equatorial. Now, here in the molecule on this side, we have this is pointing up relative here to, let's say, the plane, and this is down. I can also make a couple more drawings of the same. So let's do this, a different drawing. I'm going to make this time a Haworth projection. And what it says here, instead of have OH in carbon 1 pointing up and in carbon 2 pointing up, that's what it is. So notice it's just a different drawing of the same thing, and let's make a third drawing. Can say that. These are three different drawings of the same molecule in which we have the two OHs pointing to the same side. This is the plane of the cyclohexane, because remember in the Haworth projection, this is the plane perpendicular to the board. So this is up, up. And this is also, if this is the plane, they're pointing towards you. They are in wedges. So same spatial relationship. So these are all drawings of the same thing, cis. Now, the molecule here is completely different. Notice that we have OH up, OH down. And we can draw that, make it, again, we're going to make a couple more drawings. Let's do the Haworth projection of that. Make a squeaky noise. So let's say OH in carbon 1 is up and the other is down. Oh, and then I can yet make another drawing. And in this drawing, I'm going to put one up, one down. So this time, notice that here I have OH, OH. And I am going to erase this now so that you're not confused. I'm going to just put, for the molecule on top, the two top molecules correspond to different drawings of this. And they have the two H's pointing to the same side. So we said these are C's in the orientation in this space. This two, the two H's are pointing to opposite sides, either in this drawing or that is the same thing as that. And these are, we're going to call those trans. Either these or that. Again, these are all different drawings. If you have a question on a test asking what is the relationship between these molecules, here you will say they are the same. It's just conformers. And here's the flip chair. And here, these two are two different stereoisomers. This is the cis, and this is the trans. We're going to be doing more examples of that in next video.